This is the history of the periodic table, which is chapter 5, syllabus 1 through 4 by Riley Offit and Rory Kaltenbach.
Okay, first we're going to be talking about Dmitry Mendeleev. So he tried to organize elements according to their properties and by observing patterns. So, for example, boiling points and density. So he would have organized the periodic table by their boiling points, like which ones had similar boiling points, and then which one also had similar densities. They would be grouped closer together. He noticed the most patterns when elements were arranged in order of increasing atomic mass. So, as the elements were increasing in atomic mass, he noticed more patterns. He published his table in 1869 and he left. Okay, so if you look at Dimitri's periodic table, you'll notice that there are empty spaces, which I'll show you in the next slide, but you can notice there's empty spaces, and he specifically left those empty spaces on the periodic table because he speculated that's where the new elements would fit based on their like atomic mass and their chemical and physical properties. So he also arranged the elements in vertical periods according to their relative atomic mass. And then this is Mendeleev's periodic table that he created. So as you can see, there's a bunch of empty spaces all right here, and this is where he believed that when the new elements were added, they would fit into these spaces based on their mass and their properties, like I said in the last slide.
Okay, so next I'm going to be talking about Henry Moseley, who discovered that the elements fit into patterns better when they are arranged according to their atomic number rather than their atomic mass. So the difference between atomic number and atomic mass is that the atomic number represents the number of protons in an atom's nucleus, while atomic mass represents the total mass of the atom. So in atomic number, they're represented by the number of protons in an atom, and it can also help determine the element an atom belongs to. And then in atomic mass, it can be a little unreliable too, since there are isotopes which can vary the number of neutrons. And then Henry's first periodic table was published in 1911, although since then he and many other chemists have created newer and better versions with more elements. Through that, he examined 38 metals and discovered an unrecognizable pattern, which his work now led to the modern definition of atomic number. So this is Moseley's periodic table, which has been upgraded to more recent ones, but this is the base of ours, and it is shown going up in atomic number. So starting from 1, going all the way up into like past the hundreds, and now the chemists have created new elements where they didn't fit in between these spaces, so they had to add them beneath this periodic table where it is now the lanthanides and actinides.
Okay, so now we're going to be talking about periodic law. So Mendeleev's principle of chemical periodicity is correctly stated in what is known as the periodic law. And the definition of periodic law is when elements are arranged in order of increasing atomic number. Elements with similar properties appear at regular intervals. The physical and chemical properties of elements are periodic functions of their atomic numbers.
Last is the modern periodic table. So the periodic table is an arrangement of the elements in order of their atomic numbers so that elements with similar properties will fall in the same column or group, and then over time chemists have discovered more elements in which over 40 new ones have been added to this table. So since they have similar properties, you'll see like different elements that are next to each other on the periodic table will have same color, luster, or other things like that. And then in the periods, which are the rows, they are representing different energy levels of the electrons. And then in the groups, which are also columns, they contain elements with similar chemical properties.
And that is it for the history of the periodic table.